have new students this semester, which is awesome. We had students that went back to the building during the Christmas break, and we've had even more students come to virtual since the break. In fact, I have, let's see, since Christmas, I have 22 more students now than I did in December. 22, and that includes students that I lost. Some students went back to the school, but I've added all those plus 22 more. So, yeah, that's virtual school. There's a waiting list of people wanting to get into virtual. So, you guys are here. Glad you are here, and make sure you keep your cameras on, get your work turned in, and don't lose your spot, because there are people wanting to be in virtual that are not allowed because we don't have room. We're running out of space. Well, there's only so many students I can teach before we need another algebra teacher. And that's how it's getting with all of us. If we get too many more students, they'll start hiring more teachers. So that's why they're going to say we can only have this many students before we're just full, because I'm limited by law or whatever with so many students that I can have, and so are all the other teachers. So that's what's going on with that. But anyway, welcome. Glad to see you guys. This is the last week of January, so we're almost done. I went and saw a movie this weekend. What was that called? Face the Dark. I think that was it, something like that. But it's about a teacher who actually ends up taking in a student that he found out in high school. Found the student was living out of his car. He'd been in orphanages for like 8 years or something. And they put him in different foster homes, and he finally just quit going to the foster home and lived out of his car and was going to school. He was on the track team just so he had access to a shower. That's why he ran track at the school. And apparently he was really good at running track, but he was just in trouble all the time. He's just one of these kids that just got in trouble a lot. Didn't really have any guidance. And this teacher started learning more about him and brought him to his house to live, so he'd have a place to live. And it's a true story. That's the cool thing. It's a true story, and it kind of goes through a lot of the challenges and obstacles that they faced together, just with this kid learning to trust somebody. So it was a pretty good movie. I mean, it's not going to win an Oscar. It wasn't that well done. The directing was okay, but there's movies that make a lot bigger impact to you, but this one was really good, and you learn about the kid and the hard time he had and why he's an orphan. That's pretty rough, but it was a pretty decent movie. So anyway, yeah, but I have to say that virtual school is getting very popular. I've got a waiting list. I was out Friday. I was home. I woke up Friday morning to come to school, and my stomach started churning, and I had to run up Chuck. And I was like, oh, if I feel better, I'll get dressed and go to school. And then I couldn't stop running to the bathroom. My stomach was just in turmoil. So I didn't go to school Friday, and I went and slept 5 more hours. I didn't get up to like 11:30. And so I slept like 14 hours Thursday night and finally felt good again. And I don't think I was sick. I still take, from when I've had leukemia, I still take a chemo pill. And that pill, some days just makes my stomach turn. And that was one of those days that I had to go back and sleep more to get my stomach to calm down. And I felt good after that. I've been fine ever since then. But Friday morning, there was no way I was going to make it to school. So it was rough. But back doing well now. Probably going to be a month before I get to move home. Still delays on our house. That's just driving me nuts. I've lost my hope. Hope we'll get back home someday. But anyway. Well, at some point we need to talk about what's going on this week with algebra, don't we? Algebra 2. Let's go ahead and put this up on the screen because we got to look at the thing. Turn your cameras, folks. I see some of you don't have your camera on yet. I have been counting people absent today. Just had to because I don't even know if you're there. I know yours is broken, Seth. You're good. But the rest of you guys aren't broken. All right. Algebra 2, third period here. Let's go to our grade screen. And if we go to the grade screen, what we see is we're at the end of the unit. We're at the end right here. We are done with the exponential and logarithmic, all those functions, the graphing last week. we're down just for the test, part 1 and part 2. So that's all we have left. So with that, there's no practice test. So I wanted to pull some problems out for us to kind of practice together, things to look at, just to kind of make sure. I got you, Kelly. Thanks. Just to kind of make sure we review a little bit and kind of understand what's on the test. So I still have it open. I have some problems that I've written down that are similar to the type of stuff we've studied and things that will be something like this on the test. So some of these problems. The test has 2 parts. Part 1 is multiple choice. There's 10 questions. Part 2, you have to show your work. Oh, let me emphasize that. Part 2 is worth 40 out of the 100 points for this test. 40 points out of 100. And that is the part that has 4 questions. Each question's worth 10 points, and you have to show your work. So some of you just like to give me an answer. And then it's like, okay, well, I don't know. Did you go look up my answer? Was you trying to use AI? Did you get my answer from somebody else? What's going on? You get maybe 4 points tops for just giving me an answer. Because the important part is, how'd you get the answer? Did you know what you were doing? Did you use logarithms correctly? Did you use exponents? Were you able to rewrite an exponent as a logarithm correctly? Did you have any idea what you're doing? Or did you just guess an answer? So a correct answer is not worth very much on these 10-point show your work questions. So that's why I want to go through some of this and show you how to actually do the work. You need to show me how you got the answer. And that's worth a lot more. That's more valuable to me than the answer 3. Yeah, how'd you get that? It just seemed right. Okay, well, it seems like 4 points to me out of 10. So we're going to do some practice problems here. And if you've got questions, ask me. If you've been looking at some other problems, say, can we do a problem like this, Mr. Brock? You didn't do. Because I want you to be confident going into the test that we've looked at some of this and you kind of got a good idea what to do. So 10 multiple choice, 4 fill in, show me your work and fill in the blank type stuff. But we have the test this week. So let's look at some problems and work them together to kind of review how to solve this. So we started off this unit with problems like this: exponentials, like 9 raised to the power of x minus 4 equals 27. Say, well, that's one of the simpler ones. We got pretty complicated with some of these, right? But how would you solve something like this? Well, remember, if we can get exponentials to be the same base, like, 2 to the 4th equals 2 to the x, then it's real easy. X equals 4. You just set these equal to each other. We can get rid of the base, but we have to get the base to be the same number. So if we look at this, we've got 9 over here and we got 27 over here. 27 is not a power of 9. I can't say this is 9 squared or 9 to the 3rd or 9 to the 1st. This is not a power of 9. So I can't just rewrite that and solve it. I have to rewrite both of them. So what I do know is 9 is the same as 3 squared. So I can rewrite that as 3 squared. And 27 is the same thing as 3 to the 3rd power. 3 times 3 times 3 is 27. And this is still being taken to the power of x minus 4. So I have 3 squared taken to the power of x minus 4, and I've got 3 to the 3rd power on the other side. So we're close. We're closer. We've got the same base now. Now remember, we had our exponent rules, and we got the notes back in week 1 of that, where if you have a power, well, this is 3 to the 2nd power, and it's being taken to a power, you can multiply these powers together. So this becomes 2 times x minus 4 is 2x minus 8. Because that's 2 times x minus 4. 2x minus 8. And on the other side, we have 3 to the 3rd. Beautiful. That's exactly what we needed. It's exactly what we needed, because we want to get these bases to be the same number. And if they're the same number, then we don't need them anymore. We can get rid of those bases and just set the exponents equal to one another. This one is 2x minus 8. This one is 3. So 2x minus 8 equals 3. Now we're going all the way back to Algebra 1, maybe even 8th grade math, just to solve for x. Add 8. 2x equals 11. So x equals 5.5, or 11 divided by 2, because we divide both sides by 2, right? 11 divided by 2 is 5.5. So either they'll give us, if this is the multiple choice, they'll either give us 11 over 2 or they give 5.5, depending on whether or not they convert it to a decimal. All right. Thanks, Robin. Gotcha. 5.5 or 11. So that's how we solve when we have an exponential that's two different bases. We have to rewrite them as the same base. And then we can solve. So that's not too bad. What about when we have a logarithm? Log 3 of 1/9. It wants us to solve that. And you're like, oh, that's kind of nasty. Remember, we can rewrite it. Let's rewrite it as an exponent. So remember, if we had like log base of some number equals x, it could also be b to the x power equals y. So this, we don't know what it equals yet. So let's just say it equals x. And then rewrite it like this. 3 to the x power equals 1/9. We have to know how to rewrite it. The b is the b, the y goes over here, the x is the exponent. X is the exponent. The base is the base. So 3 to the x equals 1/9. Okay. Well, if I can get them to the same base, then I can say, well, 2 to the 4th equals 2 to the x, right? So 1/9, we know 1/9 is the same as 1 over 3 squared, right? Because 9 is 3 squared. And we know that if we move this up into the numerator, then it becomes 3 to the x equals 3 to the negative 2 power. If you move that up, the exponent becomes negative. If the exponent's already negative, it becomes positive whenever you move it from the denominator to numerator or backwards. So if 3 to the x equals 3 to the negative 2 power, then just x must equal negative 2. So that one wasn't too hard. Some of you may have been thinking, oh, we're going to do that change of base and use a calculator. Not for this one. This one we can just rewrite as an exponent and say, oh, 3 to the x equals 1/9. And as long as we realize 1/9 is 1 over 3 squared, that one's pretty simple. So all of these, you will have a problem similar on the test, because that when I was looking at the test when I made up these problems. So it might be great to have these in your notes, because remember, you can use your notes on tests. Absolutely can use your notes on tests. I don't care. Whatever notes you've taken, whatever example problems you've got, whatever formulas you've got written down, use them on the tests. All right, let's look at another problem. Let's say it gave you this equation right here. A to the x equals p, and that's a principal. Remember, if we have a starting something like a boat's worth $4,000, after 3 years, what's it worth if it's a rate of change? What's the rate of change on this? If we're multiplying it by 0.91, it's asking simply, what's the rate of change? And this is similar to one of the multiple choice questions on your test. It'll give you a formula and then ask you what the rate of change is. So let's think about, for example, let's say x is 1. So we're going to talk about 1 year or 1 week or 1 day, or whatever the time period it's using is. Let's say we started with 100 of something. We've got 100 of something, and we're going to put it in this formula. That we're starting with 100, and we're just going to do it for 1 unit at a time, 1 year, or whatever. So this is just 0.91 because to the first power is the same thing. So what's 100 times 0.91? We got 91. Right? If you're confused by the decimal thing, you can put it in the calculator just to double check. 100 times 0.91 is 91. You just move the decimal. So if you're just confused looking at this and trying to figure out, maybe something like this will help. While you just substitute in the numbers and see. If we start with 100 and we end up with 91 after the first year, is it increasing or decreasing? Hey, quite simply, we have to go, well, it's obviously decreasing. Because we have less than what we started with. How much is it decreasing? Well, we decreased 9, but start at 0.91, it decreased 9, which means if we added 0.09, that'd give us everything, right? If we multiply by 1, we wouldn't have lost anything by 1. So this is decreasing 9%. That's what's happening here. That's the rate of change. Decreasing 9%, or maybe it'll say negative 9. Or maybe it'll say negative 0.09. These are the same number. 0.09 and 9% is the same thing. But it's just a matter of reading this. If you have 0.91 left, that means you lost 9% because we still got 91%. We kept 91% of what we started with, which means somewhere we lost 9%. So that's all this question is asking. Can you look at this and tell what's the rate of change? Is it increasing or decreasing by how much? All right, so you will have a problem like this in your multiple choice part. Very simply, increasing or decreasing by how much? So you just subtract that from 100, or from 1, really. 1.1 minus 0.91 is this. 1.00 minus 0.91 equals 9%, but we know it's decreasing. That would be a positive 9. It would be 0.09, but we know it's decreasing because there's less than what we started with. It's less than 1. If it was 1.10, it's increasing 10%. Is that number bigger or smaller than 1? That's what tells you if it's increasing or decreasing. And there's a video you can go back and look at. If you want to go back and look at some of the lesson stuff before you take the test, we saw a video where he used 3 boats and talked about how this number tells you if it's going up or down. You can go back and watch that video. All right, rate of change. So they give us this formula, and I think actually they give us the graph in this problem. But we've got 3 to the x minus 2 minus 1. This is the exponent, minus 1. And it says, what is the rate of change from x equals 2 to x equals 4? And I'm pretty sure they give us the graph. So I'm going to give you the graph for that as well. Here's the graph for that equation. 3 to the x minus 2 minus 1. And here's where x equals 2. You see the graph is at 2, 0 when x equals 2. When x equals 4, it's up here at 4, 8. And wants to know what's the average rate of change. That means, what's the slope? What's the slope between those 2 points where x equals 2 and x equals 4? Well, if you want to do it on a graph, the graph, it went up 8 and it went over 2. So 8 over 2 is the slope, which is 4. That's the average rate of change. Or we had the point, 2, 0, and we had the point 4, 8. We can use that slope formula where you subtract the y's and subtract the x's. 8 minus 0, 4 minus 2, 8 over 2. So the average rate of change is 4. Either one, you're going to get 4. Either they look at the graph and count how much did it rise and how much did it run. Simplify that fraction. 8 over 2 is 4. But the average rate of change is the slope. Average rate of change, just the slope. That's all it's asking for. Okay, these I took basically from the 10 multiple choice. This is a sample of some of the ones that I thought you might get confused on. You can go back and look at the 4 assignments we've done as well, if you want to review those before you take the test. But I can guarantee you there's problems similar to these 4 on the test. Guaranteed. These 3 down here, I took from the 4 questions where you have to show your work. Now, I think these were word problems. So you may have to look at the word problem to figure out what context it's in. They were all word problems, basically. So this one, and you have to explain, you can't just give me an answer. It says Bob has $750 and he's going to invest that in an account that makes 4% and he gets paid interest monthly. Sue is going to take $750. She's going to get 5% and she's going to get it quarterly. Who has more money after 2 years? You can't just say Bob has more. You might get 1 point out of 10. And if you're wrong, I might not give you any. Maybe Bob doesn't have more. Maybe Sue has more. So you hardly get any points just for answering that. You have to show your work and explain. And it says in the problem, explain how to find that. It says use complete sentences, but in math, these are complete sentences. M equals 8 minus 0 over 4 minus 2 equals 8, 2. That's a complete sentence in math. I'm fine with that. These are all complete sentences in math. So if you just show your work, that'll do it. So how do we do that? Well, remember the amount you have is the principal times 1 plus the rate over the number of times you receive interest and the number of times you receive interest times the year. If you don't have that formula written down in your notes, I'd make sure you do. Because that's when we deal with money, that's the principal and interest formula. So let's check Bob. So Bob, how much money will he have? $750 times 1 plus 4% monthly. Come on, light. There we go. 0.04, and it's monthly. So that means he gets it 12 times a year. So 12 is the N up here as well. And they want to know for 2 years. So this is going to be times 2. So Bob's formula, 750 times, let's get our calculator and figure out what 1 plus 0.04 divided by 12 is. So the first thing I'll do is the 0.04 divided by 12. 0.04 divided by 12. And then add 1 to it, plus 1. So that is 1.020. And I'll put several 3s just to try to keep the rounding error down. 12 times 2, so he's going to get interest 24 times in 2 years. All right, let's put this in our calculator then. 750 times 1.0033333 raised to the power of 24. So Bob is going to have $812.36. Let's see, Sue. She's going to have 750 times 1 plus, she's getting 5%. For a second there. 0.05 quarterly. So she's only going to get interest 4 times a year. Bob's going to be better off with the 12 than the 4, but we'll see in the long runs if that 1% interest makes up the difference. 4 times 2, 4 times a year. So that means Sue's got 750 times 1. Let's find what 0.05 divided by 4 is and add that to the 1. 0.05 divided by 4 plus 1. So this is 1.0125 8 times. 4 times 2 is 8. So he's only Bob's getting 1.00333, but Sue's getting 1.0125, which is a bigger number, but he's getting that to the 24th power. She's only getting that to the 8th power. So let's see. Taking this to the 8th power. So that is 1.0125 to the 8th power times 750. Eight, 2, 8, and 36 cents. Sue has more. So there, if I showed this as my work in that problem, that would be sufficient. That is complete sentences in math. In math, A equals 750 times 1 plus 0.04 divided by 12 raised to the power of 12 times 2. That's a complete sentence in math. So show your work. Understand how you got the problem there, how you got there. All right, let's move over here and see this. So it has some problem, and it seems like it's talking about, there's different problems I'm talking about, like the number of crickets you have when the temperature is something or other can be found by this formula, where X is the number of crickets. And it says, how about if it's 125 degrees outside? Okay, that's a silly, it's not going to get to 125, but it was something like that. It gives you a formula and then says, check it for this, which means if this is 125, 5 to the X, what is X? So when it says convert it for convert it, I think it was check it, solve it for 125 degrees. That would be this number. Put it in for the f of X. And so now it's a pretty simple problem. 5 to what power equals 125? Well, if you don't know, 5 times 5, there's 5 squared. Here's 5 to the 3rd power, multiply it by another 5. Oh, that's 5 to the 3rd. 125 equals 5 to the 3rd. X equals 3. That's a solution. At 125 degrees, there's only going to be 3 crickets out there because they'll all be dying of heat. All right, here's the last sample problem I'm working today. You'll have a problem to say solve and explain whatever. It's got a 17x equals 11. 17 taken to what power will equal 11? And that may be a silly. Let's make it 41. Let's make it 41. Just so it's a bigger number than 17. So it's at least to the power of 1. 17x equals 41. How would we solve that? Well, there's no way that we're going to figure it out just by guessing, right? Because if we take 17 and raise it to the 1st power, it's 17, right? Because it's to the 1st power. If we take 17 and raise it to the 2nd power, that's 289. Well, 41 is somewhere in between 1 and 2. I mean, we can sit there and guess for a while. 17 raised to the power of 1.1. Oh, that's 22.56. That's not it. How about 17 to the power of 1.3? Oh, that's 39, but I'm getting close. See, you can sit there and guess all day before you get it to right to 41. So this goes back to rewriting it as a logarithm. B to the x equals y, log b, y equals x. So if we're rewriting this, the base is the base. So this would be log base 17 of 41 equals x. Log 17 of 41 equals x. Then, and I'm showing my work, so I get full credit of this, I can use the change of base formula. So this is log 41 divided by log 17 equals x. Remember, you could just take whatever the y is, put it on top, put the base on the bottom. Now these are both base 10. Now they fit in my calculator because my calculator here has base 10 right there. If I take the log of 10, it's 1 because 10 to the first power is 1. So that's base 10. So the log of 41 divided by the log of 17, x equals 1.3107. And I don't know if it's going to say round it to the nearest 10th or 100th or something. But there we go, 1.3107, which is rounded. If we want to check our work, let's take 17 and raise it to the power of 1.3107. Boy, that's almost exactly 41. Of course, I rounded it to 0.07, so that's why it's not exactly 41, but that's the right answer. X equals 1.3107. Convert it to a logarithm, use the change of base formula, 41 over 17, and it just works in your calculator then. 10 questions. Oh, there's a log 2 of 1/8. We did a log 3 of 1/9. It's real similar to that one. Use the change base formula. We just worked one that had change base formula. What's the rate of change on this formula? So this one I didn't do a sample, but it's like which of the following represents the graph of this 2 raised to the x power minus 3. That's me. I'm going to go put it in Desmos and see which one of these it looks like. 2 raised to the power of x minus 3. Which, by the way, I'm gonna put this on the screen just to talk about it. Some of you guys in earlier assignments, if you had this to solve, and let's just say it equals 8 or something, I'm just making that up. Some of you worked that like it was a linear problem. Oh, well, you add 3 to the other side. You got 2x equals 11, so x is 11 over 2. That's not this problem. This is an exponent. It's not being multiplied by the 2. It's being raised to the power of x. That is not this. So don't work it like it's an Algebra 1 problem. It's not a linear problem. This is an exponent. So you've got 2 raised to the power of x equals 11 now when you move the 3 to the other side. Or, even worse, 2x minus 3 equals 8. Some of you move 3 to the other side here. You can't do that. That's part of the exponent. On that one, 2x minus 3, you'd have to make this a power of 2. That's 2 to the third power. So then it's x minus 3 equals 3. And now you can add 3 because it's just x minus 3. X equals 6. That's the actual answer. But some of you guys just treat it like we're doing a linear problem. We haven't done linear in a long time. So don't treat it like a linear problem. Okay, I'm sorry. That just bothered me crazy because I saw it too many times. I didn't see it once. I saw it many more times. That is an exponent. So put it in Desmos as an exponent if you want to check to see which one of these graphs is. And here's one average rate of change from x equals 1 and 2, and they gave you the points. What's the slope between those 2 points? What's the rise over run? Simplified. Let's see. What's the key features? I didn't talk about the key features, but let's look at the exponential graph. What's the key features of this graph? Well, on the right, it goes towards infinity. On the left, what's it doing? It's approaching y equals 1. It's an asymptote. See, it's getting closer and closer and closer to y equals 1. Or negative 1. I'm sorry. Negative 1. I should say that correctly. It's getting closer and closer and closer to y equals negative 1 as an asymptote. That's the key features. So it gives the x-intercept on this one. Like, did we have an x-intercept? Yeah, we did it 2. And it said vertical asymptote. Let's see. Want you to write the equation to represent g of x. So this is translations. So if I just had, let me do this. I just had 3 to the x. And it wants me, turn those off. It wants me to write the equation for something else. I'll put it up there equals 3. raised to the power of. See, it may give you this one. And you just have to know translations. Look what happened. Everything moved to the right, too. Used to be over here, now it's over here. This used to be here, now it's over here. If you can see it, the translation right, you know, oh, that's right. I'm supposed to put it with the X. Put it with the X. And again, I'm putting this in Desmos, see if I'm right. I'm like, I think it's this one. Great. I'm going to go to Desmos and graph that to see if that's what it really is. So don't forget, you can use Desmos and you can use your notes on any of my tests. All right, I'm going to leave because I haven't turned in this test. Let's look at part 2. Oh, here's Larry and Peggy making decisions about their bank accounts. They both have $350. He's going to do 4% quarterly. Peggy's going to do 6% monthly. Explain which method results in more money. Show all your work. All you have to do is exactly what I did on paper there. Here's how I explain how the two methods work and which one has more money. That's how I explain it. I don't explain it with words like English class. You can, if you want to explain it with words, go ahead. But Daniel's looking at some data regarding the temperatures of countries and how that's related to the number of mosquitoes. So he gave this f of x equal 2 of x. And what about when it's 64 degrees? Convert that to a log function when it's 64 degrees. So can I write this log function? Oh, I didn't even convert it to a log function. Okay, I did that wrong there. I solved it. It said convert this. Convert, that's why I had converted there. Convert it to a log function when it's 125. So first I write it as an exponential, and then I say, so this would be log 5 of 125 equals x. That's how I convert it. Base is the base, the y goes there, the x is over there. So this is the answer it wants from there. How to convert that when it's equal to 125? Well, then I set it equal to 125, and then I convert this to be a logarithm. So if you need to update your notes on that, it didn't ask us to solve it. Once done, I convert it. Solving it doesn't get you anywhere. Doesn't get you any points because that's not what it asks to do. Read the problem. Make sure you're giving the answer what it asks for. Give the answer what you asked for. So convert this to a log function. Let's see. She's got 23 to the x equals 6. Doesn't know where to start. Solve the equation. Use complete sentences. Again, math. And it says, hint, 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 use the change of base. Well, that is very similar to our 17x equal 41. I could have left it at 11 because it would have been smaller than 1. But that's this problem. And I use change of base. Remember, there's a calculator right up here built in the buzz. And it works a lot easier than one I did. If I want to do the log of 41 divided by log of 17, I hit log first on this one. Log 41 divided by, oh, look, I put the divided by inside there. You got to hit enter equals divided by log 17 equals 1.31. That's what we had. 1.3107 is what I wrote down. But yeah, you just here's the log button. Hit the log and then hit what number do you want the log of. Remember, this is base 10. That's why that changed base formula that makes this work. And then the last one is a graph. Kylie manages a small theme park. Now, your problem may be different. This is random problems that it pulls in here. The number of visitors increase as the temperature increases, which is represented by the blue function. Also, there's a number of people who leave early, depending on the change in temperature. And it's the red one. So it wants to know, find the solution to the two functions. What's the solution to the two functions? This is actually a systems of equation problem. The solution of any systems of equation, in that right there. When you have two things on a graph, when it asks for the solutions, it's like, what do they have in common? If you have a parabola and a line that says, what's the solutions? Well, it's where the lines and the parabola are the same. Where are those points where the line and the parabola are both right there? That's the solution right there where they're both at. And there may be two solutions if it's a parabola because the line may touch it twice. So when you look at a graph and what's the solution? Well, it's wherever they touch. That point is the solution. In this case, it's where the people leaving the park is the same as the people coming into the park. That's this temperature. So, okay, so that gives you a nice look at what the test is. It took us about half the class to give you a little review. If you want to start on the test now during class, great. It's not due till Sunday at midnight, so you got all week. Take your time. If you want to go back and review, if you want to go back and look at the assignments and what you did on those, look over your notes. Take notes. If you didn't take notes, go write down. Go to the lesson summaries in each of the lessons. Write down anything in there or print it out if you have a printer. Make that your notes. You can use that on the test. So get your notes, use them on the test. Use Desmos on the test if that helps you. Some of these problems, that's not going to help you, but some of them it will. So anyway, I'm not going to keep any longer. You've got your assignment for the week. It's test week. It's just a busy week. I've got 2 bowling matches this week, but getting close to the end. Just a couple more weeks, bowling to be done. But anyways, you guys have a great week. I'll be here. If you have questions, I'll stay logged in if you want to come back and review anything. So let me know. But have a good one. This is a B Friday. So we'll have class Wednesday if you're below 70%.